Hey everybody, it's Aaron Murakami with A&P Electronic Media at emediapress.com. Our annual conference information is at energyscienceconference.com, and we have a couple forums, energeticforum.com and energyscienceforum.com. And then we have this website for the RPX and the MWOs and some other products coming out, which is vril.io. That's vril.io. And what we're going to be doing in this video here is I'm going to show you how to calculate the sidebands for Rife's frequencies, because there's a lot of misinformation out there about Royal Raymond Rife's technology. A lot of companies are selling signal generators claiming you can just put the Rife frequency in there and that output is supposed to replicate a Rife machine, and nothing could be further from the truth. Those are basically scams based on either ignorance or deception, one or the other, and has absolutely nothing to do with Rife. John Bedini was the world's leading authority on Rife up until his untimely death a couple years ago, and he is the one who developed the RPX sideband generator. I just released a video showing what the 2.0 is, which it has a switch to turn the pump wave off and on. That's on a video on the RPX page on vril.io if you want to learn more about that. And the real way to create the Rife frequencies, the way Rife did, and his partner Hoyland, who developed the sweep method, which means you're sweeping a signal generator from one certain frequency to another frequency. And so the signal generator's job is not to create the Rife frequency. It is to output a lower frequency, which is then mixed with a sideband generator, which is going to be a device which is producing a fundamental frequency. This one is 3.1 megahertz. Rife used various frequencies in the 3 megahertz range, and when you mix a lower frequency with a higher frequency fundamental frequency, what happens is, this is called heterodyning, where the frequencies mix and you produce a frequency which is the addition of those two frequencies and then the subtraction of those two frequencies. And the addition and subtraction frequencies are called the heterodyne frequencies. Those heterodyne frequencies are going to be exact multiples of the Rife frequency. What I'm going to do here is show you the calculations at how you derive the audio frequency or the lower frequency, which is to be mixed with the fundamental to produce the Rife frequency. And once you see this, you're going to see that most of the Rife's so-called Rife machines out there are completely fake, and they're not producing the frequencies the way Rife did. It was always known that the frequency was not supposed to be an exact frequency that you just focus on. It's supposed to be a little bit of variability and a little bit of wobble to it. Was always known to be what was effective. I'm not making any claims about this or what any frequency corresponds to. I'm just looking at the numbers. We're going to focus on the math, very basic math. And then we're going to verify on a spectrum analyzer that the analysis here will give you a number to punch into the signal generator, and it will indeed create a sideband that will correspond to a multiple of an exact Rife frequency, or actually any frequency. And I'll be doing a follow-up video showing this as an application to another frequency set that a lot of people know about. And this is actually the best way to do that, and I'll get to that later. So what we're going to start with is we have the signal generator, which is going to sweep through a certain range, but we're not going to sweep right now. We're just going to focus on these. This is a sheet with I don't know, maybe 15, 16 Rife frequencies that are supposed to correspond to different things. Again, no claims. I'm just looking at the numbers and looking at the math. So the first column is frequency, the Rife frequencies. The second one is the heterodyne frequencies, and then the HN is a heterodyne number, which means how many times is that heterodyne frequency of the Rife frequency. So if you take the Rife frequency and multiply it by one of these numbers, it's going to give you the heterodyne frequency. So to walk you through the numbers, we're going to start with we're just going to take the first one for easy numbers. Got a phone here I'm going to use as a calculator. We're going to do the numbers, then we're going to verify it. Okay, so first of all, what we have to basically put down first is what fundamental are we going to be using. So in this we're going to be using 3.1 megahertz, and there's a reason John chose that, which is because at that fundamental all the sidebands that correspond to a multiple of a Rife frequency is closer to that fundamental. If you do use a different fundamental frequency, then you don't get the peaks as strong, and that'll all make sense to you as we go through this. So first of all, we're going to write down 3.1 megahertz. We're going to use the full number. Okay, 3,100,000 hertz. That's the same as 3.1 megahertz. 3,100,000 times per second is the fundamental frequency. Okay, so what we're going to do is we're going to look at what Rife frequency do we want to create with the sidebands, because we don't want to take that frequency, put it in a signal generator, and claim that it's a Rife machine. That would be ridiculous. So what we're going to do is go through the process. The first one here, just as an example, is 191,000. Okay, so we're going to say this is the fundamental frequency. We're going to take the Rife frequency, which is 191,803 hertz. So this is a Rife frequency. So the first step in this is we're going to find out how many times will that Rife frequency go into 3.1 million cycles per second. You take the Rife frequency and see how many times you have to multiply it to get to this number, and it's almost never going to be a whole number yet, and we'll get to that. So what we're going to do is we're going to take 3,100,000, and we're going to divide that by the desired frequency of 191,803. Okay, so if we take 3,100,000, I'm just making sure we got enough space here. Sorry, not going to multiply. We're going to divide it by 191,803, and that's going to equal 16.16. 16.16. Now, obviously it didn't divide evenly, and we didn't expect it to, but what we're going to do is we're going to round this off to the nearest whole number, upwards or downwards. So 16.16 is closer to 16. So what we're going to do is we're going to round that to 16 times. The reason for that is because we're going to take the Rife frequency, 191,803 times 16, which is an even number. This is all about harmonics. And what we're going to do is find that the answer is 191,803 times 16 equals 3,068,848. And we can see on the chart that that's exactly what the heterodyne frequency is at 16 times. The reason we do that is because this is the target frequency that we want to create by heterodyning a low frequency plus 3.1 megahertz fundamental to get this frequency, which is going to be very close to the fundamental, which means it's going to be very strong, and it's going to be an even multiple of the Rife frequency. When I say even multiple, I mean it's multiplied by a whole number rather than any decimals. And that could be an odd number. It could be times 5, it could be times 2, 20, 15, whatever. So 3,068,848 is the closest number to the fundamental that you can multiply the Rife frequency by a whole number to get that heterodyne frequency. So now what we're going to do is we're going to take the fundamental, and we're going to subtract the heterodyne frequency, 3,068,848, and what does that equal? 3,100,000 minus 3,068,848, and we get a number which is 31,152. So 31,152 hertz is the frequency that the signal generator must output in order to mix with the fundamental 3.1 megahertz, and it will create a frequency which is the addition of those two, but the frequency that's the subtraction of the two equals the heterodyne frequency, which is a multiple, a whole number multiple of the Rife frequency. So what we're going to do is we're going to test this, and if we can put in 31,152 cycles per second, or hertz, as in sine wave output, to mix with the fundamental, and if we can create a sideband which gives this heterodyne frequency, 3,068,848, and it is at a peak of a sideband right next to the fundamental, then that means we have successfully created a harmonic of the Rife frequency the exact way that Rife and Hoyland did. And this is the real way to do it. So what we're going to do is we're going to focus on this right now, and I'm going to turn the signal generator on and the sideband generator. Let this boot up. So what I'm going to do is I'm going to select channel 1. We're not going to do the sweep mode. We're just going to straight up put the audio frequency in, mix it with this, and see if we actually get the results. I'll go ahead and turn on the scope and the spectrum analyzer. And so what I'm going to do is I'm going to make sure that the amplitude output on the signal generator is 2.1 volts, which is the max you want to put to the input of the RPX. Has a little Class A audio amplifier circuit in here to amplify that before it's mixed with the fundamental, before it goes into a RF amplifier chip. Okay, so 2.1 volts, no attenuation, no phase angle change. This is a power factor deal, no duty cycle, duty cycle 50-50. And then sine wave, we're going to change this frequency. First I'm going to zero it out. I know you can't see this, but you'll see that it's doing what I'm saying it's doing. And I'm going to change the kilohertz scale to hertz. So what I'm going to do is I'm going to go 5 places to the left of the decimal, to the 10,000ths place, and I'm going to put in 3, then 1, 1, 5, 2. So now I have the frequency of 31,152, which is in the upper audio range, and that output is mixing with the 3.1 megahertz fundamental. And we're going to verify it on the spectrum analyzer here. And so what I'm going to do is I'm going to go frequency on the spectrum analyzer 3.1 megahertz so we can find the fundamental, and you can see that peak right there, right in the middle. And then what we're going to do is I'm going to change the span, which means how much are we zooming in on the band. And so I'm going to go maybe 500 kilohertz. Let's see, maybe to zoom in a little bit more, I'll go span 250 kilohertz. So from the peak, we're going 125,000 this way and 125,000 kilohertz that way. So in the middle should be 3.1 megahertz. I'm going to put a marker on here so you can see that we are exactly getting 3.1 megahertz in the middle. So we're going to go marker. It's already set for 3.1 megahertz. There's a little number 1 right here. And what that indicates is it's right on the peak of the fundamental. These peaks on the left and the right are called sidebands because they're on the side. This is the upper sideband, that's the lower sideband. And so what we're going to see is that I'm going to select another marker, and that marker is going to be the heterodyne frequency that we're looking for, which is 3 million, or 3.068848 megahertz. And we can see that number 2 right here, right below here on that first lower sideband, that first sideband on the lower side, that number 2 is right on the peak. Why? Because we are exactly hitting this frequency on that second sideband, and it is right next to the fundamental, which means as much power as possible is being delivered to a harmonic of the Rife frequency, which is 16 times the Rife frequency, 3,068,848. So that is successfully showing that this is indeed the way to do it. and we are exactly on a peak right there. So what that peak means is that you're getting as much amplitude as possible from the output of the sideband generator, which is hitting the Rife frequency by hitting the harmonics of it. Okay, so what we see here, and just real quick, this pump wave switch off and on, you can see that this kind of looks like a sine wave up here. Well, if I turn the pump wave off, what we have here is the 3.1 megahertz in the sidebands just coming out as they would in a full power Rife machine, and if that was high enough power and it could illuminate a plasma bulb, it'd be the same thing. That's the exact same output that you would send to a plasma bulb. Now what I'm going to do is I'm going to hit the pump wave on, and the genius about John Bedini is that he has put a low frequency carrier into this machine so that this low frequency right here, square wave, at about it's around 8-9 cycles per second, has the sidebands, the fundamental in the sidebands, superimposed on that low frequency, which means this is a low frequency microcurrent delivery of the fundamental in sidebands getting past the skin effect. See, the problem with the signal generators being sold as Rife machines is that the frequency is so high it just trickles over the surface of the skin, you know, on the plant, whatever you happen to be putting it on, so it doesn't really have any penetration, and this is the issue. Once you have a low frequency carrier like this that you're superimposing the Rife frequencies on, or the fundamental and the heterodyne frequency, which is a harmonic of the Rife frequency, and you superimpose it on a low frequency carrier like this, then you get past that, and that's why this is the only legitimate electrode delivery Rife machine in the world, indisputably. And we're the only ones that have this this method.